For your research, and for all research, it's important to start with, in your introduction, with definitions of your concepts, but here in this case also definitions of the technologies. So this chapter aims at showing you how you define them, and also above all to give you a vision about what we are talking about. And that's also the aim of your research. You have to explain to the reader, to the audience, what are we talking about, and they have to define it. And so that is why we will start in the introduction to define the different intelligent objects we are working on. So namely smart objects, smart homes, autonomous vehicles, chatbots, service robots, and delivery drones. So, as you have the presentation, I won't go too much into detail in these definitions, but first of all, what is AI, artificial intelligence? AI are machines capable of simulating human intelligence to perform tasks that require human intervention. This is the definition of Hung and Rust, two marketing researchers who published in Journal of the Academy of Marketing Science. So, but they go further. The AI can be used to automatize repetitive tasks, routines, to analyze complex data, to extract insights, to predict future trends, solve problems, learn new tasks, and interact with the environment autonomously. AI includes machine learning, natural language processing, and artificial neural networks. It is used in many fields as robotics, games, voice and facial recognition, machine translation, medicine, to detect, for example, pathologies, diseases, in finance, but also in autonomous vehicles or intelligent cities or smart homes. To mention only few of these technologies where AI is used. In the future, AI will be used in a lot of more domains. We use it now, we're talking about actuality. Yeah? ChatGPT is one form of AI which is used to deal with information. It can even copy edit languages in order to improve languages. It can find your answers. So to make it short, AI will be in the future everywhere. And that is why it's also a hot topic in marketing. Huang and Rust classify AI in two types of AI, less or more complex. So at the moment we are at step 1 and 2. We have mechanical AI and analytical AI, based on no intuition. Mechanical AI is able to automatically perform repetitive tasks that do not require advanced knowledge. It is a rule-based AI that does not understand the external environment. It's the most basic level. So for example, chatbots, searching, giving information is an example of mechanical AI. We have analytical AI, which are able to process information to solve complex problems and draw conclusions. So big data analytics will analyze the information coming from big data, for example, text, photos, videos, or transactional behavioral data, which is then used and analyzed with machine learning or deep learning or other data analysis techniques to allow the AI to learn from the data and to come with learning insights without being programmed by humans, because it's a learning process, enabling then to take decisions and to make, in terms of marketing, personalized recommendations, which is based on this data. In other words, we have data from purchases, we have data from social media, we have data from geographical location, we have data from IoT, and then the AI will analyze this data and give personalized recommendations to better satisfy customers, to make them more loyal. But this is the state of code of today, AI. It's the lowest level of AI and lowest complexity, already quite complex. After having seen the basic form of AI with the lowest complexity, there's AI with the highest complexity. So intuitive AI, based on the ability of AI to think creatively and adapt effectively to new situations. This means that actually the AI is able to take directly decision without humans and take, in the situation under uncertainty, the best decision and to adapt to new situations. And the highest level is empathetic and AI, with the ability to recognize, understand, and respond appropriately to clients' emotions. That is, for example, the service recovery, when a customer is angry about, for example, a complaint management situation about a dissatisfaction, the AI can recognize emotions, so emotional AI, and can disamorce, reduce the angriness of the customer by reacting also with emotions, that is, with empathy, for example. So like humans can do, with the difference that an AI will be never tired. It can work 7 days a week, 24 hours, and it can then, in complex and highly emotional situation, adapt, recognize, understand, and respond appropriately to customers, which should increase satisfaction and loyalty. And so these two intelligences represent the most advanced generation of AI. Let's have a look to IoT, Internet of Things. So IoT is a network that identifies, interconnects, and communicates with connected smart objectives, phones, for example, watches, bracelets, wearables, and they connect via internet. Every object, so smart homes, smart cars, smart robots, are connected to smart sensors that use AI that allow them to be monitored, accessed, or controlled remotely and provide services that meet the needs of the users. This network is capable of creating and transmitting data to provide value to users through various services. The main objective is to improve the quality of life of consumers. Some examples, for example, thermostats, safety systems with self-learning systems, intelligent controllers for water, energy, and waste, connected bathroom scales, smart speakers, which is probably the most important and the most frequent device of smart connected objects, or smart TV, and connected apartments, connected flats, connected autonomous cars. Naturally, IoT is strongly related to AI because of the information processing dimension. The aim is to provide comfort, convenience, safety, health, energy efficiency through automation of the user's work. Which brings me to the concept of smart city. So a smart city is based on IoT. It's a city that links information and communication technologies and physical infrastructure to improve the quality of life of its residents, to optimize resource management, and to reduce cost. The use of sensors, AI, communication networks, big data analysis software to monitor, control, and maintain infrastructure is important. So the IoT and AI controls transportation systems, airports, communication, resources, buildings, and apartments. And it manages various aspects of the city, for example, traffic, lighting, air and water quality, waste, and energy. The main objective is to provide a safer, more efficient, sustainable, inclusive, participatory, comfortable urban environment by maximizing the services and well-being of its citizens. Here are some applications, and so they already exist. Songdo in Seoul, Korea, or in Singapore, or One Bangkok in Bangkok are already cities with smart buildings, smart apartments, smart roads, and smart transportation systems. You can see the applications are various from smart infrastructure, smart buildings, smart governance and education, smart healthcare, smart citizens for elections, smart transportations, autonomous vehicles, smart mobility, and smart energy. Here you can see more detailed information. So it's a very complex concept, and naturally strongly related to the smart city at the micro level is a smart home, which is actually defined as a residence that links information and communication technologies like smart cities, but on the micro level to a micro apartment in order to improve the quality of life, and it's based on the same technologies. The aim is to monitor and control remotely the apartment to make it safer and to automatize repetitive, boring tasks which might be perceived as a chore. They provide personalized services that meet the needs of the residents in order to increase comfort, well-being, safety, enjoyment, and entertainment. And they collect and analyze big data, real-time data via AI, about the behavior of the residents, to make remote control, to propose personalized services, to optimize decision making, and last but not least, to increase well-being and happiness. So we see we're clearly here in the hot topics of research for marketing research. There are three types of smart homes. Assistant smart homes, aiming at quality of life, health and well-being, healthcare. We have surveillance smart homes, aiming data processing to predict natural disasters such as earthquakes and in order to ensure the security of the inhabitants. And we have environment sustainable development smart homes, aiming at energy efficiency and environmental sustainability. All these three types of smart homes are not incompatible and hermetic. They are combined. So we have assistance, surveillance, and environment sustainable development smart homes, aiming different objectives. For the autonomous vehicles, the definition is that these definitions are link information and communication technologies, sensors, cameras, IoT, and AI, in order to collect data like smart homes. That's why very similar in terms of concept. In real time, they can be monitored and controlled remotely in order to navigate in a more, highest level is level 5, full automation, where everything is automatized, or less level of automation, to drive the car in a less or more automatized manner. Here is the typology. So level 5 is full automation. There are no steering wheels and no pedals to brake. No human intervention is necessary. Whereas today we are in the level 3 automation, partial automation, where the drivers does not need to monitor the environment, but must be able to take control of the vehicle at every time. So the car is driving most of the time, but the driver needs to take over the control from time to time to show to the AI that he's still aware of driving. So in other words, if the driver has a heart attack, the AI will recognize and will take over the control and stop the car in order to ensure the safety of the driver. The AI allows to take real-time decisions to avoid obstacles, follow the rules of the road, interact with other vehicles in order to increase the driver comfort. The AI will provide solutions and services which are tailored to the driver's needs, for example, to increase well-being, to give more entertainment, to also perhaps in a touristic domain, tell the driver you can go now to visit a touristical attraction. So it collects information and will more and more, based on deep learning and machine learning, offer highly personalized solutions and services, satisfying the customers, increasing his or her well-being. But the overall objective is security, because 95% of the human accidents are caused by humans. So by taking over the control and the driving process, the AI will increase traffic fluidity, so in order to avoid traffic jams, but above all, increase driver security by reducing the accidents. It would also increase energy efficiency to consume less energy. It would make driving more sustainable, because by reducing consumed energy, this will also reduce energy and resources waste and decrease CO2 emissions. It would reduce individual cost for the driver, and above all, increase quality of life through higher security, increased security, but also through well-being on board. For example, when driver can do sports or relaxing entertainment during the driving process. So here are the different levels of the, autonomous vehicles, which we have already seen. Chatbots and service robots are another application of AI. They are system-based autonomous adaptable interfaces that interact, communicate, and perform useful tasks to deliver services at home and aim at improving life quality. They can be tangible, like physical robots that can physically interact with humans, for example, give a haircut, serve food, giving messages or cleaning a house or cleaning a car. And they can be intangible, to deliver information or to communicate with a user, like chatbots or voice bots. The typical examples are Siri or Alexa as a chat and voice bots. So material robots, service robots, or intangible robots, chatbots. Which brings me to the definition of chatbots, which are conversational agents using AI with pre-programmed rules designed to simulate a human conversation. They are integrated into applications, website, instant messaging platforms such as Messenger and Facebook, and they interact with users. They answer simple questions, provide information, perform repetitive tasks, and can provide customer assistance. That is why they're mainly used in the service domain, to automatize repetitive tasks in which humans cannot contribute a lot of value, because chatbots are available 7 days a week, 24 hours a day. That is why they're a good mean to deliver information, to manage the relationship in an interactive way with the users. They're used, that is why used in domains like retail, banking, service domain, because in these domains service recovery and service production is very important. And they can use then predefined answers, learn from the data, learn from the feedback of the customers in order to improve their response capabilities. And the last definition of the research we have done about disruptive AI-based technologies are delivery drones, which is an unmanned aerial vehicle, that is why also called UAV, used for distributing packages or parcels to consumers during the last mile delivery process. It's considered as a more efficient way to deliver products than traditional delivery by truck or individual trips to the store, because drones can help to protect the environment by reducing traffic congestions and also emissions, CO2 emissions. And in terms of performance, they can deliver quicker, faster than other means of transport. And it's not an hazard that many e-commerce firms and retail companies such as Amazon, Google and Walmart are preparing to offer delivery services by drones. So we have seen now the different definitions of our research: AI, IoT, smart cities, smart homes, autonomous vehicles, service robots, chatbots, and delivery drones. Now, in the next step, it is important to see how, with the research, we can contribute to, in terms of managerial contributions. And what is the importance, what is the managerial relevance?